Okay, another one from the sum review number 7, and this is number 3. And try to fit this on this graph here. So let's see if this will work. So y equals 2 over x squared plus x minus 2 is f of x. I just wrote as y, and then I factored this. So first of all, I'm going to check for some points that are on the curve, an x-intercept or y-intercept. And when x is 0, I put 0 in 0, squared 0. So I just have 2 over negative 2, which is just negative 1. So I have this point when x is 0, y is negative 1. Now when y is 0, well, the only way y would be 0, this is a fraction, the only way it can be 0 is if the top is 0. And since the top's a constant, then not going to happen. Okay? And let's look at the degree. The degree of the top is definitely smaller than the degree of the bottom, so we do have a horizontal asymptote at y equals 0. And we have a vertical asymptote here at anything that makes the bottom 0 that doesn't divide out. So a vertical asymptote at x equals negative 2 and at x equals 1. Now this is not odd or even, okay, because if you put negative x in here, this would be the same, but this would change it all. The whole thing would come up, and then if we put so it's not odd or even. So we're kind of stuck. We're kind of pretty much have to check everything around the asymptotes. So we got both of these, so we won't be able to save any time. So let's put the asymptotes in. So the horizontal asymptote again is this line, y equals 0. And we're approaching that. And then the vertical asymptotes are negative 2 and 1. Now we usually use dashed lines for all the asymptotes, but when the asymptotes are right on the axis, we don't. And up here, I should have made this dashed line. Sorry about that. That should have been dashed lines on number 2, so you can change that if you did that in pencil. Sorry. Okay, so those are the asymptotes here. We know we go through this point. So what's going to happen? So let's see what's happening right around negative 2. So as x approaches negative 2, negative 2, let's say from the negative direction, so from this side over here. Oh, sorry, this is from the negative, excuse me. So as x approaches negative 2 from the negative direction or from the left, let's get an indication of what's happening by using a very small approach. Now you can put some points in, that's up to you. You just have to do some calculations, so let's try to do it this way, because I've seen this used in different variations. So I have y equals, we have 2 all over, that's not going to be no problem there, and then I would have negative 2 plus 2 is going to be 0, so that's going to be the problem, so I'll just write that as x plus 2. And what's this other one going to be? This won't be a problem here, so I can put negative 2 in here, and I'll have negative 2, negative 1. And really, this is going to help us find our SIGN. So this is going to be equal to 2, and this is going to be, what, negative 3 times x plus 2. Now we have to use a small approach and see what's going to happen here, because we can't put negative 2 in there because we'll get 0. So we got to put something in there that's just to the left of negative 2. So we'll write this as 2 all over negative 3. And then what's just to the left of negative 2? Negative 2.0001. So negative 2.00001, and then plus 2. We can see that. And this is going to be 2 over negative 3. And this is going to be 2 and minus 0.00001, so that's going to be negative, because this is bigger than the negative number is bigger than the positive, the absolute value. So that's going to be negative 0.00001. Okay, well, don't worry about these little numbers because they don't make much difference because we're dealing with infinity eventually. So don't worry about the 2 over the over 3, but worry about the negative. And what's a negative times a negative? A positive. So we have a positive. And then we've got 2 over 3 times a very, very small number, which is going to be a very, very big number. So we're going to have a positive infinity. That means it's going to get really, really big. All right? Because this is really, really small, even smaller. So it's going to be really, really big. So I'm going to go to positive infinity. So it's going to look something like this, or to the left. This is my asymptote here, or my horizontal asymptote. We're going to crawl up that, and it will be something like this. Okay? Now let's see what happens as I approach 2 from the positive direction. So as x approaches 2 from the positive direction, again I can just write over here, I've got 2 over negative 3 times, and this is going to be just to the right of negative 2, so it'll be negative 1.9999. Okay, and then plus 2, putting that in here. So that's going to be 2 divided by negative 3 times, and this is going to be a positive. 2 minus 1.9999 is just going to be positive 1 point, I'm sorry, not even 1, it's going to be positive 0.00001. So this again is going to be 2 over something very small, which would be infinity, and then the SIG and the sign will be negative. So it's going to be negative infinity. So that's basically what we're looking for, is how to get that SIG in. It's going to be down like this. It's going to be a little asymmetric. You know, this would be usually symmetrical, so it's probably going to come. I could probably put negative 1/2 in here, but I can see this is going to go probably something like this. But we don't know how this is going to go, so we're just going to run it through there. And then what's going to happen over here? Is it going to go up like this, or is it going to go down like that? Well, we don't know, so we have to check and see what happens around 1. So let's try that. So let's see how x approaches 1, and from the negative direction here, the left. So we'll write this again. Now we can write this okay, so this is going to be y equals 2 over, and I can put 1 here, that's all right. So 1 plus 2 is okay. I just can't put, oops, right over here. I could put 1 here, right? But I can't put 1 over here, so I'll just write that as x minus 1, because 1 minus 1 is 0. That's a no-no. So, but this is okay. So that's going to be the same thing as y equals 2 over 3, and then times this guy, x minus 1. So that's where we're going to use a very small approach. Now if we're going to be just to the left of 1, we're going to be like at 0.999999. That's almost 1. And then I'm going to have minus 1. And that's going to be equal to 2 over 3. And what's this going to be? Well, this is going to be a positive, because that's bigger than, well, it's going to be negative, excuse me, that's going to be negative 0.00001. Okay? Because negative 1 is bigger than, or 1 is bigger than 0.9999, so we use the sign of negative. And my SIG and overall, I just have one negative sign, so it's going to be negative, and I've got a number divided by a very, very small number. Even though it's 3 times a small number, it's still going to be a small number. That's inconsequential, so it's going to be infinity. So it's going to go down like this. Okay, so we have something like that. And then finally, let's see what happens over here. Now we know it could either go like this, or it could go like that. So how does it go? So let's see what happens as I approach negative, as I approach 1 from the positive direction. So as x approaches 1 from the positive direction, this way. Well, again, I can still use this over here, so I have 2 over 3. And then we're going to use, from the positive direction, that might be 1.00001 minus 1. And what do we have there? That's going to be still positive, so that's going to be 2 over 3 times, and that's just going to be, this is bigger than 1.0001 is bigger than 1, so that's going to be positive 0.00001. And we're dividing this by a very large number, so it's going to be positive infinity. So, oh, sorry, you can see that. Okay. So this is what we call a very small approach. Okay. And like I said, you could substitute some values in, that's fine. If you want to put it in there, that's up to you. But this is, we'll do more of this when we get into calculus. So you want to see that, so I'm going to go positive infinity, so it's going to look like this. So this part would be symmetrical, I guess. No, it's not symmetrical because that's 1 and that's negative 2, so not symmetrical. Excuse me. So something like this. And you could always get more checkpoints if you want to see how close it hugs that. So if we want to graph it, I already graphed it, so let's see if we got it right. So there's your function, 2 over that, and then when I look at the graph, you can see that. There's your graph. So pretty much the same thing. Okay, and again, that's how you would put it in. 2, make sure you put a parentheses around your denominators and your numerators, no matter what, because otherwise you can do some crazy stuff.